Hello and welcome to part 2 of this MATLAB to Python tutorial where we will be covering loops. So in the previous example we made a simple sine wave of one frequency. In this example we're going to make multiple sine waves of different frequencies. So let's begin. So I'm going to start on the building block of the previous code which you can see in the previous video. I'm now going to say that the frequencies I'm interested in are 1, 2 and 3. Close those brackets there. So now in MATLAB you need to make a zeros matrix, so there is somewhere for the data to go. So I'm just going to make a variable here called nFreq, which tells me how many different frequencies we have, and we just use the length function and we put this in here and that will give a value of 3. So our zeros matrix needs to be of size 3, which is defined by this, and it needs to be of length of x. So this is a rows matrix that I'm making here. And then we need to do our looping. So we say for I equals 1 to the number of frequencies that we have, so I equals 1 to 3. We now want to place the data into y, so I, row I, all of the columns, equals sine of our frequency, so frequency I times 2 times pi, times x. We close those brackets, press end, and we run that, and we have successfully made our multiple sine wave all in one plot. So I'm going to assume that everybody understands this, and now we will jump into the Python version of how to do the same thing. So the goal is to make a plot that looks the same as this. So we start off with our Python code that we made in the previous video. I'm going to comment out this line here, and commenting in Python is done using this hash symbol. And we're going to do a similar thing to before, so we'll say that freaks equal 1, 2, 3, close our list, and the number of frequencies, and this len command is essentially the same as length in MATLAB. Again, we need to make our zeros matrix, which is simply done by using numpy again, and numpy has a method called zeros, and we can see here the guidance for how to use this. So we need to enter a shape here. We can get a bit more information in this box over here of how to do this. So the inputs to this, or the arguments in, are shape as one argument, as opposed to in MATLAB where zeros takes 2 arguments in the previous example. So what we have to do here, and I'm going to leave a lot of space here to make it obvious what we're doing, I want to have a matrix of row number of frequencies, and it needs to be of length x. Now I close those brackets and I close those brackets again. So here is our zeros method, and we are giving to it this thing here called a tuple, which contains 2 integers, which are the lengths of our different arrays, which are our frequency array and the x array. This looks a little bit strange at first because in MATLAB it looks like the MATLAB version but with an extra set of brackets. But this is the Python convention, and you can read about why NumPy has that convention. So we will now go ahead and do our looping. And there's 2 ways of doing the looping. I'll start with the more MATLAB style looping. So we have for I in range 3, and we have to have a colon at the end of this for looping. So I is going to be our iterator, and the thing that we are looping over is this thing here called range 3. Range 3 basically makes an array which goes from 0, 1, 2, but not 3. So it goes from 0 to 3, but not 3. So that's a little bit of a strange thing coming from MATLAB that you have to get along with in Python, but you'll get used to it soon enough. So that Python knows what's actually inside our loop, this is all controlled with indentation. So you can see that I've automatically got a tab indentation here. So what I'm going to do now is come back to y, and I'm going to start placing the data into the right rows. So in MATLAB we have round brackets or parentheses. In Python we use these square brackets. Indexing starts from 0. In MATLAB the first row of the matrix would be row 1. In Python counting starts at 0, so the first row is going to be row 0. This is a little bit of a strange thing coming from MATLAB again, but you'll get used to it, and there's a reason why people prefer this convention. So we go back and we make our sine wave again, so np.sine, and so we say which frequency it is that we want. So we want frequency I times 2 times np.pi times x, and we close our brackets. Now when I run this should cause a crash because we need to do a transpose here. So I'm just going to run this, and we get an error here which tells us that x and y must have the same first dimension. Basically y needs to be transposed. So in MATLAB we would transpose y with a dash here, but we're in Python and using NumPy, so we do it by putting this .t. The t obviously stands for transpose, and now it runs no problem. And here we have our multiple sine waves, and we can see that all the numbers are obviously correct and the style is very similar to the MATLAB version. Some people might say that this style of looping in Python isn't a very Python way of doing it, so I'm just going to quickly go through another way of doing it. So I'm just going to quickly comment out this section here, and I'm going to say that for f in frequencies here, and we have our colon again here. So I'm going to say that I equals 0 and y, I'm just going to copy this from above. So instead of using this here, we can just simply put f in. So Python is going to loop over this array here, and it's going to assign the value each time to f of whatever is the entry at that point. So this on the first loop, this is going to put the data into the zeroth or the first row of the y matrix. When it comes around again, unless we tell it to do otherwise, it's going to put it in the same place. So we just have to manually iterate I so that I goes up by 1. If you want to save yourself a tiny bit of time, another way of writing this is to say plus equals 1. So we run that, and here we have our sine waves. I made a slight mistake there. I should have put plus equals, not equals plus. This is something that happens when you jump between different languages. So when we go ahead and run that, we get our 3 different sine waves on one plot, and the numbers are now correct. So just to talk you through what's going on in this example, I'll pull this out quickly and let's get rid of that, and we'll just go back to this example here. So we can compare this to the MATLAB version. So in MATLAB we say that I takes values from 1 to some integer which is going to be the length of this array. So in this case n is 3, so I takes values of 1, 2, 3. In our Python version we say that I in the range, which is an array which is 0, 1, 2, I takes each of those values as it loops around, and here we just index to the appropriate element of our frequencies, and we place them into the correct place in y. And that's pretty much all there is to it. So there's not a huge amount of difference in the way that you do the looping. The syntax is slightly different. You just have to be wary of using this range function, that range 3 goes from 0 up to 2, not up to 3 as you might expect. So that's a little bit of an unexpected thing, but you'll soon get used to it. That's the end of this video. I hope you enjoyed it, and see you soon.